Welcome to Open Source Spotlight. We invite open source contributors and ask them to show the tools they are working on. Today we have Willi. Willi, tell us a few words about yourself and about the tool you want to show us.
Hi, Alex. Yes, I'm Willi Müller. I am partner of the Untitled Data company, and I've been working as a freelancer, data engineering freelancer for a couple of years. And today I'd like to show the DLT REST API source because I've been contributing to it. And this has been emerging from client work, actually. So we had one company, a US-based startup that does analytics as a service for HR, for human resource departments, and they wanted to they considered starting to use DLT, but what they found is that they wanted some easy system to develop dozens of custom sources. So they've been using Airbyte, and they had some problems regarding scaling and also regarding the license terms. So therefore, they were they were considering to use DLT. And but what they liked about Airbyte is that they offer a toolkit to develop custom connectors. So they reached out to us and said, is there some way that we could have something similar with DLT and using DLT as a backend? So DLT is a library that that is used to quickly build data pipelines and load data from unexpected places and running in unexpected places too. So, yep.
What are those unexpected places? I'm really curious now.
Yeah, I'm gonna, okay. Should I say now? I can also speak about at the end, but unexpected places are, we've been using it in a bunch of systems now in the field, and ranging from startups to startup APIs to Oracle NetSuite, or some point of sales system for restaurants, or a sales asset management tool, iAsset. So in so many ways, we've been using it over the past month.
Interesting.
Yeah.
To be honest, have no idea in practical terms how it would look like and what. Uh, but yeah,
Okay.
maybe at the end you can tell us more about that.
Yeah. Yeah, maybe I can say one more thing regarding the history. So, what I'd like to say is that, um, so this client, they came to us and wanted to have some kind of framework to develop dozens of connectors quickly and have maintainable code. So then that means I and my partner Francesco Muccio, he then developed a prototype using DLT and showed it to the people at DLT Hub, the company that has been developing the DLT data load tool library. And they said, yeah, this looks nice. And actually, there has been another person from another company, it was Alex from Harness, um, who has built something similar. So maybe, maybe this indicates that there's some kind of demand and maybe we should do it together. So then this was in February and March a bit, I think, mainly February 2024. So then Anton from DLT Hub, he then developed most of the tool, and Francesco and I, we've been design partners because we had specific requirements from the client, from the field, and then we also had the client company. This was Ethan from Equitable, with their requirements, and they were testing it also while it was being developed.
Interesting story. Okay, so you want to show us what you eventually came up with, right?
Absolutely, yes. Okay, so here I have this little Colab notebook, and the first thing we've got to do is to install it, right? And how I'm installing it right now is I'm using the alpha release for the 1.0 version that's going to be released very, very soon. And I'm doing it because some little details are going to change. Okay, now to get this warning out, let me just delete this file. Okay, good. So let's install the library here. So we installed DLT with the DuckDB extension, and we're using the alpha version here, the pre-release candidate. And so we see that this was been successfully installed. And then we initialize a REST API pipeline here. Okay. Now then, the first thing we've got to do is we can declare an endpoint, or we can declare the source. And now the special thing about this REST API source is that we declare everything using Python code, and specifically using dictionaries. So what we do here is we import DLT and import the REST API source. And now what we say is we need a client. So we specify how to connect to all of the endpoints. We're using as an example the Poker API. And then in this resources, list of resources, we now can put a list of dictionaries, which each dictionary gives us one endpoint. So in this one here, I'm going to load from the Poker API, I'm going to load the /berry. So let me run this.
So the full URL would be pokeapi.co API v2/berry, right? So
Exactly.
you can concatenate the base URL with the path. Okay.
Yep, that's exactly what it does. And now we have declared it, and now we can run the pipeline. And what it's doing now is we declare, okay, this is called Pokemon pipeline. We load into DuckDB and we call the dataset Pokemon. And here we see how it's loading. And after a few seconds, it got loaded successfully.
What
Wonderful.
was actually being loaded? Like, what did it actually do? Did it just send a request to this /berry? And what happened next?
What happened next is that, let me show maybe the data that got loaded. So what we have now is a DuckDB where we have these tables here. We have berries and then some metadata. So inside berries, let me select from that. I did here already. Now we have the list of berries, yeah, that is returned by the Poker API.
So it
So
returns a list of things, right? And then you just figure out what to do with the items in this list.
exactly. So what it returns is the berry name and the URL. So what we have loaded here is a list of, so what the API returns is a list of tuples of name and URL, such as cherry and then /berry/1, chesto /berry/2, and so on. And then DLT, the library behind it, also adds a couple of metadata columns. Yeah, so each column is uniquely identified, and then each load is also uniquely identified. Okay, cool. So this is all we got from this simple configuration where we said, okay, give me the /berries endpoint. Now, when we want to have multiple endpoints, such as we want to have the berries, but then also we want to have berry details, which we get by /berry/berry name. Okay, then we add to this list of resources, we add a new dictionary where we say, okay, we call this here berry details, and this is the URL path where we want to get it from. And now the thing that is inside these curly braces, this is going to be resolved from the berries resource, because there it will take the field name. Okay. And then again, I declare the pipeline here and load the thing. Let's go. So it loaded it, and let's inspect the data. Okay. And now what we see is two things. So earlier we just had the berries table, And now we have two more tables, berry details and berry details under flavors, it will say. And why this is the case is that, let me select here star from berry details, okay? So now let's look into the berry details. This is how it looks like. So we have the firmness, we have firmness, URL, growth time, and so on, so many fields. And yeah, but then the question is, why do we now have these berry details under flavors? And the reason is that berry, so the flavors is a list that is nested inside the berry details. So I have a link here to the API documentation. Let me zoom in, right? So, oh, link didn't work. Berries, yes. Here we are, berries. So this is how the reply looks like, okay? So we have slash berry and then slash ID or name. So now we see here firmness is an object with two keys and then items, and now flavors is a list, okay? So now what DLT does is that whenever there's a list, then it will create a new table where all the elements of that list are being stored into. Okay, so this is why we have also the flavors table here created in our little DuckDB. And we see that we have 3 pages here. So we have now 73 different berries. Good. Now we might want to say that now we come to really cool features which sets the REST API apart from previous work. Now we might want to say that actually I don't want to have all these berries. Right, I don't want to have all 60, but or 73, I want only 10. So what we can do is we can say, hey, we can add the key here, processing steps. And here again, this is a list of dictionaries. And here we can say, please make a filter. And here we can pass a Python callable, such as a lambda, where we say, okay, now looking at this berry record, return only those which have the ID less than or equal to 10. Okay. And then we can also say, actually, I don't want to have all these columns. It's also fine if I get all columns except the natural gift type. Okay. So here we see natural gift type, and then here we have a name and URL, and I want to omit this. So in practice, with the real system, this would be something like, we can use this functionality to do anonymization or to, drop data that is too large or unnecessary so that we don't ingest it in the first place. All right, and how is this exclude columns implemented? Again, we have a Python callable here that iterates over the records and then just pops the columns from the dictionary. Okay, let me execute this. Here's the configuration. Here's our source. And now it's loading, and it finished. So now let's look again at the berry details and see how, what has happened now. So if we scroll around here, then we still see the natural gift, right? We see the natural gift type name, natural gift type URL, but it's empty here. And here it is still present for these records. So oddly enough, the first 10 records don't have these values, but all records that come afterwards, they have it. And the reason is that, and now we see also 4 pages here in our result. So why is that? I thought we had omitted all the berries which have an ID which have an ID which is larger than 10. And the reason is that our write disposition, so the way we insert the data into the database, by default, the write disposition of DLT is append, which means we just append to the table, and in each load we get more and more data. So we have to change that Here's a link to the documentation if you want to check it out at your own time. So we have to change it to right disposition, replace. Yeah, so this replace will replace existing data, will truncate the table and then load the new load. And what I'm also doing here is I say for each endpoint, please add also the parameter limit with 1000. So that in case the default is 10 or 5 or 1, we need to do less requests and we load faster and put less load onto the API. And the other thing I'd like to highlight is here, instead of now repeating this parameter limit for our two resources, which is our berries and then our berry details, we can also declare here resource defaults, which will be applied to every single resource. Okay. The other thing I'm going to do here is, sorry, there are 3 steps now. So the other thing I'm doing here to make it load faster is that I put the filter into the berries resource, which means the list of berries, that endpoint which returns me the list of berries, this will now only load those which are, up to 10 in their ID. And because previously we were filtering here in these berry details, which means we first requested all 60 berries. And then for all 60 berries in a loop, the source here would request the berry details for each of these 60. And then, for berry number 11 to number 60, it would conclude that, oh, this ID is less than 10. This ID is larger than 10, therefore let's not load it. So I put the filter up, yeah, so that we only load those which have an ID up to 10. And now I had to change the filter here a little bit. And so how the data structure looks like is that we have the URL, it looks like this. So we just split on the slash, sorry, and get the second last element. And this way we can filter here by this number. Okay, wonderful. Apart from that, the code is still the same. So let's execute it, and we'll see that it's also faster than before. And here we have our berry details. And now note that instead of 4 pages that we had before, we only have 1 page here, and we only have 10 records. So it indeed worked that we limited the berries. We loaded only the first 10 berries, and then, so we see here ID is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then we got the berry details for that. And yeah, and we don't have the natural gift type because we dropped that field over there, right? We said exclude columns. Cool. So now let me maybe take a break here and say my personal design highlights of this project is that what I really like about it is that the configuration uses executable code. Thus, it's very easy to generate also these types of resources or resource declarations, and it's also very easy to debug it. Whereas in other systems that I used before, they used YAML. Oops. They used YAML or they used JSON. So you would program in YAML or you would program in JSON. And this can be a little bit difficult to debug also because you can't just easily set a breakpoint and step through it. And it can also be difficult to then, or require a little bit of, gymnastics, I'd say, to include then callable code, right? To embed some lambda function or some other object. Yeah. So
But in
therefore,
terms of like all the logic is still inside the library, right? So if you want to debug that, then you kind of need to step into the library.
yes, exactly. Yeah, yeah. Cool. And also what I really like about the REST API source is that low-level stuff like pagination is automatically inferred. You can also override it. And that's the next thing. that you can override almost anything here, whether it's authentication or pagination or these processing steps that we saw or result actions. That's another very low level thing I'm going to show in a minute. So having these variation points and not having to switch now my mental model from, oh, I'm in YAML world and now I have to go to the Python world, but staying in the Python world all the time has been very beneficial and I find it very elegant. Yeah. So for me, it looks like, let me demonstrate this little GIF here. So I spoke about gymnastics. It's like this guy here, you know. Um, so it's something quite complex, but it looks just so smooth and easy. So that's what that's how I would describe the REST API source so far. Yeah, here on the Pommel house. Okay.
And how do you change how do you pass these Python callables? Like, do you just do this in the dictionary, right? In the config?
Yes. Let me show you one example. So I have one example here with authentication. Yeah. And here inside the client, we define an authentication and we, if I would run it on my laptop, I would fetch it from DLT Secrets, which is a secret provider here. I get it from this collab like this. And in this way, we can load, for example, all the issues that are in the DLT project. Yeah. But if I wanted to pass something callable, it would look like this. So for example, here we have Freshdesk, which is a CRM. And here I can declare this HD basic auth class, yeah, and parameterize it with my token and then pass it here inside these dictionaries. That's how it looks like. Okay, and this is a really working pipeline, no joke. That's all you need to get all the tickets out. Okay, or another example here. If you wanted to load using OAuth, yeah. So here again, we declare the OAuth credentials class. So where we have to put our secret URL, access token URL, where it, requests the temporary tokens, and then uses these client ID and client secret. And then again, we just put it here inside the auth. We can even implement custom authentication. For example, this is here a custom OAuth variation that is used by Zoom. So that's from a pipeline I built, which fetches then the meeting metrics. So yeah, I won't go into details, but basically you can either use this syntax that you put in here, the callable object into the dictionary, or you can also register your custom auth and then still use this dictionary type of configuration. So then instead of putting all these fields here into the constructor of the object, you would put it here in this dictionary form. So let's go back to our GitHub pipeline. We wanted to load all the issues, right? And here we are. It loaded it. Let's inspect our issues table. And we see we have an exception. Good. Table with name issues does not exist. Do you mean github.issues?
Because it's still trying to load from Pokemon.
Let me see. I thought I
I
executed
saw that
this.
in the table.
Okay. In the table.
Yeah, like in the table that you just showed us, schema is Pokemon and database is Pokemon pipeline.
No, I thought I executed this. Right, let's go. Okay, so here we have our GitHub issues. Okay, I forgot to execute this part here, it seems. Good. So now what we see is we have our issues. And again, just that we had before with the berries, right? Whenever there's a list, then it unpacks it and puts it into separate tables. And this is here the describe of our Pokemon database. And now we need to load from issues. Okay, I think you were right. Pipeline, exactly. So I have to change this into GitHub pipeline. Good. Let's do it again. Wonderful. So here we have our issues. Yeah. So many fields, so many things. And this now ran because we have the authentication enabled. Okay. And if we wanted to say, okay, give me only the issues that were created by me, and then I could do it like this, right? I add just more params, and I can also add, I can also filter issues, such as if I want to have issues only that were loaded after I loaded issues the last time. Yeah, this is called incremental loading. Then I can say, hey, please use this parameter of type incremental and use the updated add field that is inside the issues and start with this initial value. And then instead of overwriting or appending, what we want to do is we want to merge it with the existing data that we have already in our issues table on the ID as a primary key. Okay, so in this way, we have also implemented incremental load, which is very important to speed up the data loads, right? So that we don't request all the data all the time. Cool. Let's make a pause here. Is there any question or anything you would like to?
No.
Good. Yeah, then maybe here to conclude my demonstration, let me maybe just speak briefly about how we've been using it professionally. So as I said before, right, we have Oracle NetSuite, we have this IACID sales pipeline, Smartsheet, Freshdesk, Zoom, then here's some HR systems like Greenhouse and Workable, or this point of sale system that's used by restaurants, Rebel, and all these very different APIs that I've been working with over the past few months. For all of them, this REST API has been working. Yeah? And I'd like to conclude also with some little, let's say some little war stories. So, because APIs can be really, really crazy. But every time we encountered something really crazy, then we, found a workaround using the, really nice base that Anton has implemented, or we implemented some additional features. For example, let's say the endpoint responds with the Unix epoch, right? So this integer timestamp. But then when you request the endpoint, it wants to have an ISO timestamp, right? So this thing that we did here before, that we say, okay, cursor, just take the updated add field and request that from the API, so this would generate a URL where we have, question mark and then since equals, whatever the value is that is currently at the cursor of updated add, the maximum updated add. This doesn't work, right? Because we have an integer here, but it wants a timestamp. So therefore, we did here in the incremental configuration, we added the special conversion function or conversion API that you can put also callable inside, which is called before the incremental processing start. So in this way, you can, convert from one format to the other. Or let's say results are encoded in some ancient encoding, and the requests Python requests API doesn't detect it automatically. So then what we did is we implemented something called response actions, which is again just a list of dictionaries or callables, where we have an API now which gives us the raw response. Okay, and we can, for example, then set the encoding manually, and only after that it will be handed over to DLT so that it can do the JSON processing. Yeah, maybe one important thing to say. So this REST API here, it works with JSON responses only. Yeah. Or another crazy thing, I think that's the last. So we had one API. This is workable. So you have candidate offers, yeah. So you fetch them from /candidate/ID/offer, okay. And but whenever a candidate doesn't have offers, so we are in human resources here, then the API returns a 404 and doesn't return just an empty list. Okay. So what we then implemented is that you can have a response action where you ignore certain responses or response codes. So you can ignore on status code, or you can ignore on having a certain substring in the response, these kind of things. Or, this was also really funky. The response does not include information, any information that this is the last page, okay? So it is pagination, but it doesn't say, oh, if you call me once more, then I will crash. And if you call once more, if you say, give me the next page, then you get an internal server error. So what can you do now, right? Because automatically you can't detect if there will be another page or not. So therefore, one solution was that we manually specify the single page paginator, and you can also request the API to return all the, luckily you can request the API to return all the results in the single page. So in this way, we can work around that kind of problem. Yeah, I said this would conclude my little presentation here on the DLT REST API, which is a framework to declare REST API, to declare pipelines that load data, JSON data from REST APIs in a way that is very simple to write and simple to maintain. Because what we do is we have a declaration-based approach. So you pass in Python dictionaries instead of having JSON or YAML declarations, and also instead of having imperative code or very object-oriented code that requires more skills in programming. However, if there's any instance where this configuration-based approach is not suitable because the API is just too complex, then you can also use, instead of the REST API source, you can also use the REST API client, which is the load-level interface that is behind this configuration. So this configuration here that we give, it actually generates an instance of the REST API client and works with that then. So you can also have this imperative interface that is available.
And typically at this point, of course, I want to first thank you for the presentation. Typically at this point, I am asking questions about the tool, but the thing is we already had a DLT, presentation of DLT, and this is a specific feature of DLT. So I think what we can do is we can skip these questions, and if somebody is interested, we will link the previous episode, previous recording demo of DLT. But I still want to ask you one thing, Willi. So at the end, I usually ask for a piece of advice. So I want to ask you, do you have any advice to anyone who is watching this?
Yeah, so my advice would be that you're probably watching this because you have to load data from a REST API, and you found this through Google, or because you're following Alexei's channel. So my advice is to just try this tool out and let us know how it's working. Because what we've seen is some interesting anecdote. So when we started developing it, then some people at DLT Hub, they thought, are people really going to use this? Dictionaries, I don't know. This DLT here is something more low level for data platform builders. And then we were all surprised that after a few weeks, this was one of the most popular sources. And so popular that now for the version 1.0, they're also moving it into the core of DLT. Before it was just inside a separate module or a separate repository, the verified sources. So now it's really part of the core product. And yeah, I think that's really cool. And why this happened is because we had, we just had clients, we just had users who wanted something like this. And then the people at DLT Hub developed it. And I think this is something this shows maybe very nicely that this is how open source can be very successful. That if there's some real world use case, some, really some problem. Someone wants to migrate from the other system off, wants to use the new system, and the new system doesn't look like he wants it to look. Yeah, and this was a really great inspiration to get this into a shape that is very useful for actually already thousands of people.
Yeah, thanks a lot for a great demo, for presentation, for all the stories. That was super interesting. So it was great pleasure to have you, Willi. And also thanks everyone for watching this. And last but not least, please do not forget to give DLT a star.
Thank you very much, Alexei. It was a fun to prepare this and to walk through it with you together.